Hello everyone, I'm Peihang-ChatTwin from the University of Cambridge, and today I'm going to introduce our work ChatTwin, which enables natural language interactions with infrastructure digital twins. And in this work, we are using a road digital twin as a representative example of infrastructure digital twin, but this framework can be used and adapted to other infrastructures with minor modifications. And here you can see an example use case of ChatTwin where the user is asking for the defect information within the road digital twin, and the system responds with a summary of the information requested by the user. So it has been a challenge for the road asset owners and operators, and more broadly, infrastructure asset owners and operators, to maintain and operate their assets throughout the life cycle. This is because the maintenance and operation activities and the decision-making processes requires the integration of a large amount of data from different sources. Digital twins have been developed as a platform, a solution, and a unified platform to provide data integration and analysis capabilities. However, it has been shown that the digital twins might be difficult to use for people within the construction sector because they don't have extensive computing experience, and some of the digital twins also have very user-unfriendly interfaces like this, with functions cluttering at the top and organized into tabs, and information scattering around the place, which might cause information overload for the user and make it difficult for them to find the information they really need quickly. This might prevent them to utilize the full potential of these powerful digital twins. So in this work, we're proposing to replace all of these unintuitive and user-unfriendly interactions with a more natural and intuitive ways of interaction, which is natural language interaction, so this way of interaction is more natural to human because they use this way of interaction in their daily life with humans, and users can frame their requests in natural language, and the system will be able to process the requests and respond with also in natural language. Currently, the system is capable to do 5 tasks. The first one is data visualization, which enables the user to visualize a specific time series data. This is typically from, for example, roadside sensors. The second task is data summarization, where the user can ask the system to summarize specific information from the digital twin in the form of natural language. The third task is performing changes to the digital twin. For example, here, the user can ask the system to change the status of a defect from scheduled to fixed. The fourth task is module visualization, where the user can ask the system to visualize a certain section of the road digital twin. And the fifth task is work schedule inquiry, where the user can ask the system to generate and visualize a work schedule based on the information stored within the digital twin and visualize it as a Gantt chart. These tasks were selected because they were the most commonly performed tasks with road and infrastructure digital twins. So the system has mainly 3 main components. The road digital twin, which stores all the information about the road. The examples database, which has example questions and answer pairs that can guide the large language model to produce more relevant and accurate responses that we want, and the large language model, which is used to process and analyze the user's prompt. So the whole process starts with the user providing a query in natural language to the ChatTwin system. The system will then retrieve the relevant information from the digital twin and the relevant example from the examples database. ChatTwin will then collate all of these information into a structured prompt and send it to the large language model. The language model will then produce an output and send it back to the system. The output is then analyzed, and the system will produce a natural language response to the user, and sometimes also a command to the digital twin to perform the requested actions. So here we can see the system in action for the first task category. And here the user is asking about the historical data in a specific sensor. And you can see that the system is able to recognize the user's intent and retrieve the relevant data and visualize it as a chart. So we're going to have a look at how it works in the background. So it all starts with the user submitting a query in natural language. Then the system will retrieve the relevant example from the examples database and put it into the input into the language model. And then it will append the user query at the end of the prompt. Then this prompt will be sent to the language model, and the language model will follow the examples provided within the guidance provided within the examples and produce here in this example a Python script that can produce the data visualization requested by the user. This output is then sent by the system to a Python interpreter, and the interpreter will then produce the visualization requested by the user. Here is the system reacting to performing the second task, which is data summarization. So the user is asking for the defect information within this, the digital twin, and you can see on the right-hand side, the system is able to generate a natural language summary of the defect information and attach the relevant information that they think the user might need in the case of this request. So we'll also see how this how the system will process this kind of task in the background. So it also starts with the user providing a natural language prompt. This time, similar as before, the system will retrieve the relevant example from the examples database. And then this time, the system will also retrieve the relevant information or data from the digital twin, and then also append the user query at the end of the prompt. This is then sent to the language model, and the language model will be able to produce an output according to the examples provided to produce a natural language summary of the information requested by the user. And here we can see the system performing the third task, which is performing changes to the digital twin. So here the user is asking the system to change the status of a defect to severe, because the defect has developed over time. And we can see that the system can perform the change to the digital twin and then return a feedback to the user that this has been successfully executed. And the fourth example is the user asking the system to visualize a certain junction within the road digital twin, and you can see that the relevant point cloud data is retrieved from the digital twin and visualized on the right-hand side, and the user can interact with the point cloud to see the data that they want. And the final example is the user asking the system to generate and visualize a work schedule based on the defect stored within the digital twin. and the system will then retrieve the defect information and the prioritization criteria within the digital twin, and then generate a work schedule and visualize it as a Gantt chart. So in conclusion, in this project, we are trying to replace the user-unfriendly, unintuitive, and complicated interface that we normally see in these digital twin products with a more natural way of interaction, which is natural language interaction using our ChatTwin system. This might have also some broader implications to other users as well. For example, the policymakers who might need the road asset information to make policy decisions, and even the general public who might be able to use these information within the digital twin to make decisions on their use of roads, and even possibly more users because of this more intuitive way of interacting with the complicated data within the digital twin. Despite the capabilities, we also identified some potential areas that could further improve our system. The first area is enhancing feedback. For example, when the user is interacting with the system might be able to provide information on what it is doing at the moment, or providing a more comprehensive verification of the results of the execution, so that to build the user's trust with of the system. The second area would be expanding the scope of tasks beyond the current 5 tasks to adapt to more use cases. The third one is multi-turn interactions. So for example, the system will be able to refer to the history of chat and to to retrieve information from that to see what the user might imply in future interactions. For example, here, the second request of the user is referring to the defect they are referring to in the first request, and the system in this case would be able to recognize that and retrieve that information and execute the action requested by the user. And there is also possibility to do a more comprehensive user study to learn how they feel about this system and to improve upon that. There is also possibility to integrate the language modality with other modalities such as the traditional graphical user interface, or even extended reality, to combine their strengths and provide a better user experience. And finally, also evaluating the performance of the system with different LLMs, so that to explore the possibility of deploying it locally for better data security. Thank you.